All right, for this problem, it says a rocket launches with a velocity of 550 miles per hour. Now, think about a rocket. It's launching off, so shooting up, right? So, velocity is the derivative of the position function. So, when it says the velocity is 550 miles per hour, then that means that if this is labeled x, which I know most people would label that y, but let's just stick with it, then this derivative of x with respect to time, that would be 550 miles per hour. All right, 25 miles away, so 25 miles away, there is a photographer filming the launch. At what rate is the angle of elevation? So there's my angle of elevation. So at what rate is that angle? So the derivative of the angle with respect to time, that's what you're asked to find. When the rocket achieves an altitude of 25 miles. Remember, altitude is height. So, in other words, when x is 25. Okay? All right, well, since you're talking about angles, obviously you're going to have to use sine, cosine, or tangent. Well, if this is my angle, this is the opposite side, this is the adjacent, what trig ratio would you have to use? You'd have to use tangent. So, tangent of my angle would be x over 25, but at this instant, the value of x at the altitude is 25 over 25. So I'm going to have 25 over 25, which is 1. And then to solve this for the angle, I'm going to do tangent inverse of 1. And you can use your calculator to find that value, but I'm going to hit tangent inverse of 1, and that's going to give me 45 degrees. So that's basically a 45-degree angle, which in radians, that would be the same thing as pi over 4. So my angle is pi over 4. Okay, we're going to use that later. But first, let's just write out my formula. My formula for tangent for this problem will be tangent of theta is x over 25, opposite over adjacent. All right, and then I want to take the derivative of this with respect to time of tangent of theta. So the derivative with respect to time of x over 25. And so the derivative of tangent is secant squared. So I'm going to have secant squared of theta equals the derivative, and then I'm going to need d theta over dt, right, because the variables didn't match. All right, equals the derivative of x over 25 would be 1 over 25, but the variables don't match, so that would be dx dt. All right, you're asked to find what's the rate of change of the angle. So I want to solve this for d theta over dt. Theta, if you remember, was pi over 4. So I'm going to have secant of pi over 4 squared d theta over dt. And then dx over dt was 550. So I'm going to have 1 over 25 times 550. All right, now I need to figure out what secant of pi over 4 is and then square that. So off to the side, I'm going to just remember that secant of pi over 4 is the same thing as 1 over cosine of pi over 4. And then cosine at pi over 4 is square root of 2 over 2. So that's 1 over square root of 2 over 2. And so I'm going to leave the 1 alone, change its multiplication, and then flip this. So that's going to be 2 root 2. So that's going to give me 2 root 2, and then I'm going to rationalize this, so multiply by root 2 top and bottom. That's going to give me 2 root 2 over 2, and then the 2's are going to cross out, so that'll just be root 2. So secant of pi over 4 is root 2. If I square the square root of 2, that's just going to give me 2. So I'm going to have 2 times d theta over dt, and then 1 over 25 times 550 is going to give me 22. And then to solve this for d theta over dt, I'm just going to divide by 22. And so I get my answer is 11 degrees per, I think that was second was originally, nope, degrees per hour. So in other words, that angle is increasing at 11 degrees every hour. Because that, if you notice, the rocket's going to be shooting off, so that angle is going to be getting bigger. So it is increasing.